Okay, here we're going to look at solving quadratic inequalities. I'm going to do this by graphing. Later on, you'll learn other ways to solve these by making a sign chart. If you're in a college algebra course, you'll do that when you get to polynomials and rational functions. And then in pre-calc, you'll just in general learn how to solve nonlinear inequalities using a sign chart. This is just another method that works particularly well with quadratics. And I do it by graphing. Okay, so our goal here is to solve something that looks like this, some quadratic with a greater than or less than. We may or may not have a zero here on the other side. The way we're going to do this is first, make sure we get a zero. So our first step, get zero on one side. Our second step is whatever the left side is, we're going to call that y equals the left-hand side. And then we're going to graph that. Forget about the greater thans, the less thans. We'll graph y equals our quadratic. So we know how to graph quadratics. In fact, we're not even going to draw a very detailed graph. We're just going to find the x-intercepts and then roughly sketch the graph. So we find x-intercepts. How do we find x-intercepts? By setting y equal to 0. So we're going to start with something that has a greater than or a less than. We're going to ignore the greater than and the less than. What we're doing is just solving some function equals 0 to find x-intercepts. We sketch the graph. And then we look at the graph to see where it's positive or negative. And when I say positive or negative, I'm talking about y values. So, we want to do this guy right here. X squared minus 6x plus 8 greater than or equal to 0. That's our first example. Okay, the first thing we're going to do is forget about the greater thans and the less thans. We want to think y equals x squared minus 6x plus 8. We're going to graph that guy. Hey, we're really good at graphing quadratics. We know the y-intercept, we know how to find the vertex. Don't really care about either of those right now. All I really want are the x-intercepts. I want the x-intercepts. I find x-intercepts by setting the function equal to 0. Plug in y equals 0. So I get x squared minus 6x plus 8 actually equals 0. So sometimes that leads to confusion because it looks like I just went in a circle. And in a way I kind of did. What I'm really doing is I don't care about the greater than or the less than. I'm really just solving where does this thing actually equal 0? Where is it going to cross the x-axis? Okay, we know how to solve this. Just factor, quadratic formula, completing the square, whatever your favorite method is. I'm going to factor. At this point, you should immediately see that that's how that factors. If you don't see that that factors that quickly, you better go practice factor. Okay, I have two factors that multiply to 0. So set each one equal to 0. And honestly, you should see immediately what your two solutions will be. X equals 4, x equals 2. So we have x-intercepts 4, 0, and 2, 0. So I'm going to quickly sketch this function. I'm not going to draw a real detailed graph. All I care about is I have an x-intercept at 2, 0 and one at 4, 0. A is positive, so the graph points up, so we'll get some graph that looks roughly like this. But where's the y-intercept? Where's the vertex? Don't care. Not worried about that at all. This is a rough sketch of the graph. So that's the graph of y equals x squared minus 6x plus 8. Now, really for the first time, I look and see what I was initially trying to solve. I want to know where this graph is bigger than 0. So I want the graph, the y values, to be positive. So we look here. I'm looking vertically now. Where are the y values positive? So at that y value right there, is that positive or negative? Oh, that's positive. What about this y value? That's a negative. What about over here? It's positive. See, these x-intercepts break my graph up into 3 separate pieces here. Back here, for all of these x values, back here, y is positive. On this chunk of the graph, y is positive. Over here, all those y values on that graph are positive. In this chunk in between here, the y values are all negative. I'm below the graph. We're thinking above or below. Above is positive, below is negative. So in between 2 and 4, these x values, the y's, are negative on the actual graph. What did I want? I want positive, greater than or equal to 0. So all of these x values have positive graph. All of these x values have positive graph. The question isn't asking me about the y's. The question's asking me for which x values is the graph above the x-axis. So that's all of these x values right here. That's an interval, negative infinity. Excuse me. Up until this x value, 2. Infinity always gets a parenthesis. I have greater than or equal to 0 here, so I want a bracket on my 2. And then, again, from 4 to infinity. So union 4 to infinity. So that's my solution. My solution is always going to be some interval or some union of intervals. Okay, let's look at some more examples. We have x squared minus 8x plus 15 less than 0. Okay, so I'm going to forget about the less than for a minute. I'm thinking I want to sketch y equals x squared minus 8x plus 15. Just a rough sketch of it. First thing we do when we're trying to sketch these graphs is find the x-intercepts. So we solve x squared minus 8x plus 15 equals 0 for the x-intercepts. That's how we find x-intercepts. We plug in y equals 0. We'll worry about the less than at the very end. Okay, this factors. That's x minus 3, x minus 5 equals 0. I get 2 answers. You should just be able to see that gives you x equals 3. That gives you x equals 5. So my intercepts are the points 3, 0 and 5, 0. Okay, now we quickly sketch the graph of this guy. Forget about the greater thans, the less thans. We sketch y equals x squared minus 8x plus 15. X-intercept at 3, 0. X-intercept at 5, 0. A is positive, so the graph points up. We wait until this moment. Now is for the first time I look and think, what do I want? Positive or negative? I want y less than 0. Ooh, looky right there. So I ask myself, for which x values is y negative? We're looking vertically here. We're asking about y values. Our answer will be, for which x values are the y's negative? So I have 3 different sections of graph. For all of this, those y's are all positive. Above, remember, up here is positive. Down here is negative. Above the x-axis, below. All of this chunk is all positive, so there y is positive for all of these x's. In between, here we're down below. Look at that. Whoa, way down there. Those y's are negative. Over here, these y's are positive. I want the negative ones. So these are my relevant x values. All of these x values in here. From 3 to 5. Do I want to include the endpoints though? No, I don't have less than or equal to. If I had less than or equal to, I would include the endpoints. So I kind of want some open circles here. So everything between 3 and 5 gives me negative y values. So my solution will be 3 to 5. Parentheses, because we had the open circles, because we did not have an equal to. If we had an equal to, we would put solid dots, square brackets. Okay, another example. We want to solve x squared is less than or equal to 25. You're tempted, I know you are. Oh, let's just take the square root of both sides. You can't do that. It doesn't work out mathematically. When you take the square root of both sides, you got to put a plus or minus on one side. So you're essentially multiplying both sides by a negative half the time. You don't know if you have to flip. Remember, when you multiply by a negative, you have to flip your inequality. There's a way to do it like that, but it's so much work. This is much easier. First thing you always want to do is get a 0 on one side. Get everything to one side. So x squared minus 25 less than or equal to 0. Move the 25 over. So now this is who I care about, x squared minus 25. I want to solve x squared minus 25 actually equals 0. Because I want to sketch y equals x squared minus 25. And I want to see where the x-intercepts are. This is how we find x-intercepts. Okay, that's a difference of squares. That factors x minus 5. X plus 5 equals 0. We get 2 solutions there. X equals 5 and negative 5. Okay, now we can sketch our graph. Y equals x squared minus 25. We have an x-intercept 5, 0. Another x-intercept at negative 5, 0. Negative 5, comma 5. Okay, now we can draw the graph. We are sketching this guy. Y equals x squared minus 25. A is positive, so the graph points up. There's the graph of y equals x squared minus 25. It's not a perfect graph. I didn't label the y-intercept, which happens to be the vertex. I don't care about that. All I really care about are the x-intercepts. Now we go back and look at this problem. What did we want? We don't want to look at the beginning. We want to look once we got the 0 involved. So I want, because of right here, I want x squared minus 25 less than or equal to 0. That's what we called y. So we want y less than or equal to 0. Y negative. So we want the part of the graph that's under the x-axis. Positive y's are above, negative y's are below. So we look over here. What part of this graph is below the x-axis? I like to draw in these little dotted lines here. So this chunk right here, is that above or below? That's above. That guy's positive y's. All of this stuff in here is under. These are all negative y's. And this chunk here, those are all positive y's. I want negatives. I want the negative portion. That's everything in here from negative 5 to 5. Okay. Brackets or parentheses. We have the equal to here, so we want brackets. So there's our solution. By the way, we could easily check this, see if this is right. Here's what we were originally trying to solve. Let's pick something in here and see if it works. So as a check, let's see. 0's in there, 1's in there, 3, 4. Maybe we'll pick 3. 3's in this interval. So is 3 squared question mark less than or equal to 25? 3 squared is 9. 9 is less than or equal to 25. Looks good. Okay, one more example. All right, we got this guy here. X squared minus 2x, or x squared plus 2x minus 3 is greater than 0. Okay, now what I would do if I had this problem, I don't like having a negative in front of my x squared, so I would either move everything to the other side or multiply through by a negative. I would get a positive x squared. But let's say you didn't notice that. You just had this function greater than 0, and you said, okay, so let's sketch y equals negative x squared plus 2x minus 3. Forget about the greater thans, the less thans. As long as you have a 0 on one side, call this side y and graph that, whatever you get. Okay. This guy here, you should be really good at graphing quadratics. If we wanted to find the x-intercepts, we would say y equals 0 for x-intercepts, because that's really the only thing we care about here. And we get negative x squared plus 2x minus 3 equals 0. It's a 0, not a 6. Okay, if we're going to solve this, we could factor and get some negatives in there. I don't like having a negative when I'm factoring in my leading coefficient, so I'm going to get rid of that negative by dividing everything by -1, both sides. And we get x squared minus 2x plus 3 equals 0. Okay, will this factor? Well, we are looking for two numbers that multiply to be 3 and add to be -2. So 1 times 3 would be 3, 1 plus 3 would be 4. No, we're not going to be able to factor this. We would have to use quadratic formula. Okay, so quadratic formula would be x is opposite of b. Opposite of -2 would be 2, plus or minus the square root of b squared. -2 squared would be 4, minus 4 times a, 1, times c, 3, all over twice a. So we get x squared is 2 plus or minus, inside here, order of operations, -4 times 1 times 3 would be -12. So I get 4 minus 12. 4 minus 12 would be -8. And right there I can kind of stop because I see immediately that I'm not going to have any x-intercepts. I have a negative under the radical. My discriminant was negative. These are complex. Square root of -1 is I. We get complex solutions, so no x-intercepts. Okay, so what's that going to mean for this graph? If I want to graph this function, I'm going to have to think a little more on this one. This graph points down because we have the negative leading coefficient. So the graph couldn't possibly look like this. That would have some x-intercepts. If the graph is going to point down, it must live all underneath the x-axis. It must live down here somewhere. Because there are no x-intercepts and it points down. So the original question is, where is this graph positive? This graph's never positive. It's always below the x-axis. So this graph, y, is never greater than 0. So there's no solution. What if the original problem had been less than 0? Well, then the graph would always be less than 0. It's always below the x-axis, so then the solution would be all real numbers. Everything would work. In this case, nothing works, so there's no solution. Okay, in order to do all this, you had to be really good at graphing quadratics, so that video should be popping up here. Take a look at that one. I also had to be good at quadratic formula here. That should also be popping up. So watch those videos as well.